Good morning students, welcome to my channel Chemistry with DNA. I'm NAUMAN AHMAD and today we are going to discuss the remaining topics of physical chemistry in chemical kinetics for BSc part 1. Today I have selected the topic that is Lindemann and Lindemann's both. Lindemann's theory of unimolecular reaction. This is the topic, Lindemann theory of unimolecular reaction, which is the most important. Now see, this is one of the most important topic in the physical chemistry. And what is basically this? This is let me represent it with a chemical equation. Suppose there is equation two molecule A plus A, and when they react with each other, they will form a product that is A star plus A. This is a kind of reversible reaction, and the rate will be K1 for the forward reaction and K minus 1 will be for the reverse reaction. And this A star is nothing but it is more energized molecule. It has more energy, or we can say more vibrational energy. So this is nothing. A star is nothing. This is not activated complex. It has more energy as compared to the parent atom. So that's why we have put a star on it, that it is more energized, or we can say it has more vibrational energy. Now the rate for K1, A and plus A2 molecule will combine to form A star plus A. This is the step 1, and it is, as we can see from the arrow, this is reversible. Now these two will react. The rate will be K inverse 1 and they will form A plus 1. And the second step is for A star. This A star is more energized molecule, so it will form product. So this is reversible reaction, but this is not reversible reaction because it will directly convert into product. Now here there is one assumption which is called steady state approximation. What is steady state? In some books you might have studied SSA, steady state approximation. Steady state approximation is nothing, just rate of formation minus rate of consumption minus rate of consuming is equal to 0. So here the rate of for first reaction is K1 and A square. This is called K1 A square. A square means these two will form K1, rate is K1 for this reaction, the forward reaction, minus, now these two will form this K inverse, these two will react to form again this reaction. So K inverse A star will react with A to form again this is reversible, यानी इसका जो रेट होगा वो ये होगा और इसका जो रेट है वो ये है, ठीक है, माइनस, now A star, this is K1, this is K inverse and this is K2. For this rate is K2 forms K2 A star will be written on it is equal to 0. Now this is the most important reaction which is called steady state approximation. Now let's continue it. Let me remove from the upper portion. Now see, you have to remove this and the remaining part take it to the upper side of the next side of the 0. So this will become plus and this will also become plus. So the rate, this will be removed. K1 is equal to, now when this portion, just take it from here and just take it over there, so this sign will become positive, so I am not going to write it. So k minus 1, k, this will a star and a is right like the same. This minus will go there to form plus k2 a star. So this is a kind of reaction. So we have taken this, from this equation we have taken this equation. Now see, just take out a star from this equation, a star, the value of a star. So the remaining will be a, it will go there, k1 and a square. Now see, the remaining will come with this side, but we will not write a star and a star because we have taken it like in the form of a star. So this will be written in the denominator. We will not write this, we will write only a. हम ये नहीं लिखेंगे क्योंकि ये और ये हमने कॉमन ले लिया यहाँ पे. अब रिमेनिंग हम इसके साथ लिखेंगे plus k2 this. This is important relationship because we are going to use this value in the coming equation. So this is important. Let me write it, important relationship. This is very important. So you must keep in mind, this is the most important topic of BSc. So that's why I have written it most important. Now see, let me remove the remaining part. Now this is becoming so easy. Now the rate of formation of the product. This is now the remaining part. Rate of formation of product, which is rate of product is we know k2 a star. So in place of this we can say rate is equal to k2 a star. Now in place of a star we can write this equation. So what will be the rate is written like this, and k2, and in place of a star we will write this equation, k1, we will write k1. Now see, k1 and a square divided by k inverse a plus k2 will be written k inverse a plus k2. This is the another relationship of this equation. So now here two conditions are very important. I am removing the upper portion. Now there are two cases. The most important cases, two important cases we are going to discuss in this portion. What are the two important cases? Case number 1 and case number 2. This is case number 1 and this is case number 2. Case number 1 says when this one is very, very high as compared to k2, and k inverse a, this one, is very, very high than k2. And the second case, when this k2, and we can say k inverse a, is very, very smaller than k2. When the pressure is very high, in this case, when the pressure is very high, when the pressure is very high, in this case when the pressure is very low, very low, so what will happen? So this we will discuss, but before discussing this, now see, in this case, now see, if this is very high in this one, so we will not write the case which is very high. We will ignore one substance. Suppose this is a kind of substance, if this is very high, so we will ignore K2, and when this is very high, we will ignore this one. So in the first case, we will ignore K2, and in second case, we will ignore this substance from this equation. So this equation will be like the same. R is equal to, when we ignore K2, this one, so what will be the reaction? K2, K1, A square divided by K inverse and A. We will not write K2. So this will cancel this. So the remaining will be, rate will be K2, K1 divided by K inverse and A. So what is the order? The order, when it is cancelled with, then it is 1. So in this case, this reaction will be first order reaction. First order reaction. This is very, very important. You need to know, you need to memorize this thing. Whenever when we in this equation case, there are two important cases, case 1 and case 2. In case 1, when this is in K inverse A is greater than K2, so we will ignore this one. We will not write in this formula. So the equation will become like this, and in this case the rate is equal to first order. This is first order reaction. Now in the second equation, if we just cancel this one, let me remove this one. Rate will be K2, K1, A square divided by K minus 1, A plus K2. Now in second case, this is it has high value, this is low, so we will ignore this value. We will not write. So the rate will become, what will be the rate? The rate will be K2, K1, A divided by, we will not write this one. This is totally ignored because when the pressure is very low, so we will write only K2. So K2 will cancel K2, so the rate will be R is equal to K1 A square. And in this case, the order is second order. So this is very, very important on conceptual point of view. In two cases, when this is greater, this is smaller, so we will ignore this one. So the case will be like the same, and that will give you first order reaction. And whenever in second case, when K inverse A is smaller than K2, so we will ignore this one and we will put only the value of K2. So in that case, it will give second order reaction. So these are very much important. Now we are going to compare it experimentally. This is now experimentally rate of reaction is given. Let me remove. Experimentally. Now experimentally rate. Now experimentally the rate of the reaction, yeah, we can say rate of the reaction is given. Rate. Now experimentally the rate of reaction is given. What is that reaction? Now in that reaction we can say that a rate is equal to, for unimolecular, this is a rate of reaction, experimental rate of reaction. So if we just we can say that in a rate, just bring it here on this side, to K unimolecular is equal to rate will be there, and for A star. So in place of rate, we can use our value, that is, very well, we just derived from the previous one. That's why we will be writing this equation. K uni is equal to, in place of K2, K1 is K inverse A plus K2. This is the reaction. Let me write it. Ku and I reaction is equal to K2 K1 A, and in this case, because in that A2 will not be, so there is mistake, 2 we will not write 2, and K inverse and K2 will be written because this is 2 now, so in place of this they will cancel it, so we will write only this. So there is a mistake, we will not write it. Okay, now see, this is the, now we will plot a graph. Now can we draw the graph, but before taking graph, let me take the reciprocal of it. Let me write it. Let us take the reciprocal of this equation. So when we'll take the reciprocal, so what will be the reaction? The reaction is very important. How? This is the reciprocal. In term of this, we will write K inverse 1. This will be the reciprocal. K inverse K2 K1 and plus. And what will be the reciprocal of the third one? This is the reciprocal. This is we just took the reciprocal of this equation. So this is another equation in which we will make it and show it in the graph. So let me remove this is the last section of this equation. Now we will plot a graph and we will show how the graph looks like. So this is a graph, this is x-axis, this is y-axis. So this is, we can say that this is in equation, this is y, this is of course m, no, so this is a concentration C plus this is m and x. This is a kind of relationship we will so here on y-axis we will write 1 upon this is, and of course we are taking it 1 upon this 1 upon A concentration. On axis we have taken 1 upon A, and 1 upon K uni will be on the y-axis. So there will be a slope will be there, but from here we can say a kind of slope will be there. Here this portion that will be represented K inverse. This portion is K inverse, that is K1 and K2. This is K inverse, K2 or K1. This is constant. This is a slope, we can say it. This is a kind of slope we will make it. And basically what is this slope? This slope is 1 upon that K1. So this star is very, very important. This graph is important. You need to learn how to take this on the y-axis. You will take the reciprocal of that equation, that will become like the same. So this is y, this is x, this is constant, and this is m. You will bring this on this equation. You have to show it, and this is the end of the topic. So Lindemann theory of unimolecular equation is very important on examination point of view. Whenever there is a topic, so you should learn the basic things. What is Lindemann equation? You should write the equation. You will steady state approximation will apply in it. Rate of formation of A star is equal to rate of formation of A star, you will write, and then you will step by step you will do it. At the end you will take the reciprocal, and also the graph is very important in this case. I hope you enjoyed the video. Again, if there is any question, you can ask in the comment section. Take a very good care of yourself. Assalamu alaikum.